Okay, so we were studying projectile motion. In the last lecture, I told you that acceleration in the y direction will be minus g, acceleration in the x direction is 0. The velocity in the y direction is v sine theta, this vertical component, and velocity in the x direction is v cos theta. Okay, it's very simple. If I ask you, or let me define something, let us assume, let us say total time of flight is equal to t, capital T. So as you might have guessed, range r will be equal to horizontal velocity into total time, because this is nothing but the total horizontal distance traveled by the ball. And you already know that there is no acceleration in the x direction. Okay, so since acceleration is 0, so throughout the journey the ball will continue to move horizontally with v cos theta. Suppose the ball at any instant is here, its velocity will decrease, let us say it becomes v dash, but the horizontal component of ball will still be v cos theta, because there is no acceleration, so it will continue moving with v cos theta. Okay, so the range will be v cos theta into capital T. Now how to find out this capital T? What is the total time of flight? Okay, now I want you to know that in projectile motion, or not just in projectile motion but in any kind of motion, the vertical motion is independent of horizontal motion. Okay, so we solve for vertical and horizontal motions separately. So if you want to solve for the horizontal motion, what you need is horizontal acceleration, horizontal velocity, and then we'll solve for the horizontal motion. If you want to solve for the vertical motion, then you need vertical velocity and vertical acceleration. Okay, so just see, in this projectile motion, let us talk about the vertical motion. If you see, this is the vertical velocity. As the ball is going up, its vertical velocity will keep on decreasing, and finally at the highest point, the vertical velocity will become, I'm really sorry, just a moment. Yeah, so initially the vertical velocity is v sine theta, and as time passes by, the vertical velocity keeps on decreasing, and at the highest point the vertical velocity becomes 0, and again the vertical velocity starts increasing in the downward direction like this, and finally here the velocity is again maximum. Okay, the vertical motion is under the effect of minus g. So just look at the vertical velocities. I will apply the kinematics equation to the vertical motion. So I know that v is equal to u plus at. This is the first equation of kinematics. So I am applying it for vertical motion. So I will write vy will be equal to uy plus ay into t. Okay, let us put the value. What is the final vertical velocity of the ball after it comes back? So after it comes back, its final velocity will be v sine theta only, but it will be in the downward direction. Okay, and I've taken the upward direction as positive and downward direction as negative. So the final velocity is nothing but minus v sine theta. Okay, initial velocity is plus v sine theta, plus acceleration in the y direction is minus g, because acceleration is acting in the downward direction. The time of flight, the initial and final velocity, the time between initial and final velocity is capital T, which is the total time of flight. So solving it, I get capital T as 2v sine theta upon g. So this is the total time of flight. Okay, so we have successfully calculated the total time of flight. Now coming back to range, I've already told you range is equal to horizontal velocity into total time. So this will be v cos theta into 2v sine theta upon g. So this will be 2v square sine theta cos theta upon g. And I've already told you, or if I've not told you, then you might be knowing that 2 sine theta into cos theta is nothing but sine 2 theta. So let us put it here. If you can see this thing, 2 sine theta cos theta, so this will become v square sine 2 theta upon g. This is the range. Okay, so we have calculated two things. We have calculated the range, we have calculated the total time. Now if I ask you what will be the maximum height. So maximum height, to calculate maximum height of projectile, we have to calculate a quantity which is related to the y coordinate. We actually have to calculate what is the maximum y it is reaching. So again we have to focus on the vertical component, vertical coordinate system. Okay, so let us take another equation for vertical. V square is equal to u square plus 2as. So for vertical it will become vy square is equal to uy square plus 2ay into sy. Now I want to calculate the maximum height reached. I've already told you the initial vertical velocity is v sine theta. What is the final vertical velocity where the height is maximum? Vy will be 0 because it is at the highest point. So the Vy will be 0. So 0 square is equal to initial velocity is v sine theta whole square. Acceleration is minus g and displacement is h max. So from here we get h max is equal to v square sine square theta upon 2g. Okay, so we have calculated all the three quantities. Let me just write it here. So h max is v square sine square theta upon 2g. Okay, total time of flight is 2v sine theta upon g, and range is v square sine 2 theta upon g. Okay, so we have calculated the three quantities for the projectile motion. Okay, so in the next video lecture we will try to find out some important some important properties of projectile motion. We'll discuss about some important properties of projectile motion, and if time permit we will go on to a different kind of projectile motion where the projectile motion starts from some vertical height. This is the projectile motion where the motion is starting from horizontal point and the final point is also same vertically. the vertical point is same. If you are starting from a certain point, you are ending at the same point. In the next lecture